problem. You got the archer. He's going to shoot. His bow is 4.8 degrees above horizontal when he shoots. Okay, the target, the center of the target is 1 meter off the ground, so I don't have this drawn to scale, sorry. And the question is, where should he set the target so he hits the bullseye? In other words, how far over should he set the target? So, therefore, are you finding X or Y here? We're trying to find X. Okay, first thing you should still do, though, is immediately fill in those parametric equations. So, my xt, what's my velocity? Oops, I didn't tell you velocity. Sorry, I better tell you velocity. How fast is he shooting? He's shooting at 60 meters per second. Okay. So, my velocity then is 60t cosine of what? 4.8 degrees. And my y equation, okay, gravity, which one am I using? I'm in meters. Yeah, so I'm going to do gravity, so it'll be half of that, so it'll be negative 4.9 t squared. How do you always do your middle term? Same as above, just put sign in it. Okay, now, in this one, do we have an initial height? Yes. It's 1.4 off the ground when he fires it. Oh, well, it's because I'm doing last problem, and that was the number I was using. Sorry. I'm still on the old problem. It has an 8 in it. It has an 8. You're right. Because I was talking and not thinking about what I was writing. Very simple. Okay, so those are your two equations. Now, in this case, since we know we're going to solve for x, we need to know the x value. Guys, could we can all the conversation in the back row? This is the algebraically tricky one to get figured out a little bit. If I need to know x, that's what I'm supposed to find, is how far over should it be. That means that I have to figure out something using y then.
Okay, well, we
so what's that? Okay, we know that the bullseye is 1 meter off the ground, so where would I put 1 meter?
Y.
Y is 1. And so 1 equals this lovely equation. What am I going to have to solve for? I'm going to have to solve for t. How on earth am I going to solve for t?
Oh my gosh, it's like factoring or quadratic formula stuff.
Okay, well, you think you're going to factor it with a sign in the middle of it. It is going to be a quadratic formula. We need to set it equal to 0, and then we're going to put it in the quadratic formula. Hey, at least you can do it with a calculator. So I'm going to move the 1 over, which is going to actually make this then on the end just 0.4.
Where did the 1 come from?
They told you it's 1 meter off the ground. So you know y is 1 meter. So I'm going to actually have 0.4 when I subtract my 1 over to the other side. You can fill that in the quadratic formula. It's just a little bit ugly, but you have calculators. You won't die from it.
Yeah, I will.
Okay. The big question here is, what's negative b?
Minus 60 sine of...
Yeah, that whole thing is times t. So b in this case is 60 times the sine of 4.8. Okay. Plus or minus the square root of, so you'll have to do 60 sine of 4. The number one thing is watch your parentheses. They're gonna, it'll put parentheses around your angle, but then to square this, then you're going to need another set of parentheses around the whole 60 sine of 4.8 to get it squared. So be careful of the parentheses. So that's b squared, then what? Okay, and so in our case, a is negative 4.9, and c is 0.4. All over 2 times our negative 4.9. Okay, so yeah, it's a little messy. It's actually way easier with these calculators. It's way easier to enter now.
So don't have to actually plug that.
Just put that whole thing in a big fraction in your calculator and let it do its work.
Well, the negative 4.8,
So,
you change that back to 9.8.
when you solve this, now remember, there's a plus and a minus. So you're going to have to do both answers and then ask yourself which one is the logical one. So you're going to, in one of them, you're going to get a negative 0.074, and the other answer is going to be about 1.0989.
Okay, the first one, when you
Okay. Yeah, can time be negative? Can you go backwards?
No.
So, no, it's not that one. So it's got to be the 1.09. Now this, I stole this, your handout, I actually stole most of these problems out of a book. They tended to round this off, they take it to 1.1. They're not always consistent. If your answer's really close but not exactly the same, it just may be a matter of where you rounded versus where they rounded. Cause yeah. Okay. Is that the answer to my question?
No.
Okay. That's how many seconds it's going to take the arrow to get over to the target. How do I answer the question? Yeah, so since I now know it's going to take 1.1 seconds, if I want to know horizontally how far will that be, then yes, just put that into your x equation, which was 60 times our 1.1 seconds times the cosine of 4.8, and let it tell you how far over. And unfortunately, when I printed this, it cut my final answer off, so I don't know the final answer. So, 60 times 1.1 times cosine of 4.8.
What do you think was my run?
Because time, I'm filling in the time. Thank you. 65.8 when rounded? Okay. And that would be then meters, how far over we should put the target. Okay. And guys, if you think about it, if you are the military and you're shooting artillery out of your tank or a missile, they're really going to care about targeting that. This is exactly what it all works on.
Otherwise you're gonna miss it.
Exactly. So, and that's why you make sure you've got it down to a science before you start firing at real things. So, that's parametric.